Arborist Podcast, Domain 2, Episode 2, Soil Texture, Structure, and Pore Space, How Soil Physical Properties Affect Trees. Welcome back to the Arborist Podcast. This podcast is designed to help you study for the ISA Arborist Certification Exam by breaking down complex topics into clear, practical explanations. As always, this podcast is not affiliated with or endorsed by the International Society of Arboriculture. It's an independent educational resource created to support arborists preparing for the certification exam. In the last episode, we talked about what soil is and why it matters so much to tree health. Today, we're going deeper into soil physical properties by focusing on soil texture, soil structure, and pore space. These concepts explain why some soils drain well, others stay saturated, and why roots struggle in compacted sites. Why soil physical properties matter. Soil texture, structure, and pore space determine how air and water move through soil. They directly influence either root growth, oxygen availability, water drainage and retention, nutrient movement. From an exam perspective, these concepts come up frequently because they explain many real-world tree problems. If you understand these physical properties, soil behavior becomes predictable instead of confusing. Soil texture explained. Soil texture refers to the relative proportions of sand, silt, and clay in the soil. These particles differ mainly in size. Sand particles are the largest, silt particles are medium-sized, clay particles are the smallest. Texture is a permanent soil property. It does not change unless soil is physically removed or replaced. This is an important exam point. Characteristics of sand, silt, and clay. Sandy soils have large particles and large pore spaces. They drain quickly, hold little water, and often dry out fast. Oxygen is usually plentiful, but water and nutrients may be limited. Clay soils have very small particles and very small pore spaces. They hold water tightly, drain slowly, and can easily become poorly aerated. When compacted, clay soils are especially restrictive to roots. Silt soils fall between sand and clay and often have good water holding capacity but can compact easily. Most soils are mixtures of these particles called loams. What is soil structure? Soil structure refers to how individual soil particles are grouped together into aggregates. Good soil structure creates stable aggregates with spaces between them. These spaces allow water and air to move through the soil and provide room for root growth. Unlike texture, soil structure can be improved or destroyed through management. This distinction is critical for arborists. Soil structure and root growth. Well-structured soils allow roots to grow easily between aggregates. Poorly structured soils, especially those that are compacted or crusted, restrict root penetration and reduce oxygen availability. Urban activities such as foot traffic, vehicles, and construction often destroy soil structure. Once structure is lost, roots must expend more energy to grow, leading to stress and reduced vigor. Understanding soil pore space. Pore space is the portion of soil volume not occupied by solid particles. Pores can be filled with either air or water. Large pores called macropores allow air movement and drainage. Small pores called micropores hold water that roots can access. Healthy soil contains a balance of both types. Compaction and pore space loss. Compaction reduces pore space by pressing soil particles closer together. This reduces macropores first, which limits oxygen movement and water infiltration. As pore space decreases, root respiration becomes restricted, even if the soil contains water. This explains why compacted soils often lead to decline even when irrigation is adequate. How texture, structure, and pore space work together. Texture influences how soil behaves naturally. Structure determines how well that soil functions. Pore space determines whether roots can breathe and access water. A clay soil with good structure can support healthy trees. A sandy soil with poor structure can struggle. The ISA exam expects you to understand these interactions, not just definitions. Practical arborist applications. Understanding these concepts helps arborists diagnose soil-related stress, recommend aeration or soil remediation, choose appropriate tree species, set realistic expectations for tree performance. When trees show stress symptoms, soil physical conditions should always be considered as part of the diagnosis. Let's recap the key points. Soil texture describes the proportion of sand, silt, and clay and does not change. Soil structure describes how particles are arranged and can be improved or damaged. Pore space controls air and water movement and is essential for root function. Together, these properties determine whether soil supports healthy tree growth. In the next episode, we'll focus specifically on soil water, drainage, and aeration, and explain how too much or too little water affects tree health. Thanks for listening to the Arborist Podcast. Let's keep building your arborist knowledge, one topic at a time.